Alright guys, welcome. This is Professor Roldan. This is College Algebra Chapter 1 review. I'm going to go through this at a decent pace, assuming that you already know the information. I'm not going to actually be teaching it. So we have 50 questions to go through, and let's go ahead and get started. Alright, so first we have graphing using a table. So basically, you want to plug in the x values for into the equation or the function and calculate your y values. Okay, and all this is saying is that you're going to be squaring all your x's. So we can just quickly go through this and say this is 9, 4, 1, 0, 1, 4, 9. Okay, so this is definitely a parabola, as the numbers are the same for the -3, like the -3, the number is the same, and the +3, the value is the same. So this is definitely a symmetry here, which we'll talk about in chapter 2, but you can tell that this is D. It's a parabola, open up right here. Okay. It's not linear, these are linear over here. And this is basically negative x squared. So we'll talk about in chapter 2 how the negative has reflects over the x-axis. Okay, let's take a look at number 2. And so this is saying cube the x and then add 8 to it. So -3 cubed plus 8. Okay. So you can just use your calculator. The easiest one to start with would be this one. 0 plus 8 is 8. -1 to the third power. Let's just do the positives first. 1 to the third power is 1, plus 8 is 9. 2 to the third will be 8. 8 plus 8 is 16. And 3 to the third is 27. 27 plus 8 would be 35. Okay, and then up here, so -1, so this one's going to be a -1 plus 8, which just gives us 7. And this is a -8 plus 8, which is 0. And -27 plus 8, which is -19. Okay. All right. So which one looks like that one as far as ordered pairs go? So we can go to the 0, and it should be at 8. Okay, so that would be, it would not be this one or this one. Okay, and then you can do, let's say, the 35 right here. Okay, and 3 and 35, that's definitely around over here. Okay, just using one of the extreme points. Okay, all right. Let's move on to number 3. Okay, so it says determine the x-intercepts and the y-intercepts. Okay, we can just take a look at this. So x-intercepts will be here. Okay, and so for your answers, basically you would just do -1, comma 1, okay? And then for the y-intercept is right there, and that is 0, -1. So for the y-intercept, you just do one of those, okay? Let's go start doing some solving. Numbers 4 and 5. So let's see how much room I have here. Okay, so distribute, to get rid of the parentheses. Whoops. And so we have 3x minus 15 plus 17 equals 2x plus 3. Get the x's to one side and all the numbers to the other side. Actually, we can combine like terms right here. I'm going to move the 2x to the left, making it x, and I'm going to move the 2 to the right by subtracting. 3 minus 2 will be 1. Okay. Okay, so let's move on to number 3 here. This is just identifying x and y intercepts. So you can see that the x-intercepts are in red, okay, and those go in the first position, -1 here, and +1 here. So those are the actual coordinates, but the order pairs, I'm sorry, but in your answers you just want to list the two x-intercepts, and then for the y-intercept it's -1. That's what it looks like, but they just want you to put a -1 here, okay? Next, let's go to number 4. And so we're going to have to work through some of these directions or whatnot. So we're going to distribute to get rid of these parentheses. So that's going to give us 3x minus 15 plus 17 equals 2x plus 6. And I'm going to combine the -15 plus 17, which is 2. Subtract the 2x from the right, and subtract the 2 from the left on both sides, so that's going to give me 4. Okay, so the solution to that will be 4. Next, same thing, just a little bit longer. Clear the parentheses first. So we have 8x minus 72 minus 9x plus 72 equals x plus 8 minus x plus 5. Okay, and then we're going to combine like terms. So these two cancel out. These two cancel out there. So we have 8 minus 9 is -x. And we have 8 plus 5 is 13. Divide by -1 and you get -13. Okay. Let's go to number 6 and 7. Here we have fractions. We want to go ahead and get rid of those fractions or clear the fractions out by multiplying the whole equation or both sides of the equation by the LCM. So the LCM in this case will be 12. So multiply everything by 12. So that is going to look like, it's probably easier to look at it when the 12s are next to every term. That's my opinion. Okay? And that way we can do the division. So on the left side, we have 12 divided by 3, that's 4. Then we have 12 divided by 4 is 3. And then we have 108. Then subtract the 3 from both sides. It gives us x equals negative 108. And that's our solution set. Number 7. LCM in this case is 15. Multiply everything by 15. And we have 15 times that term, 15 times this term, 15 times this term, and 15 times this term. So here on the left we have 30 divided by 5 is 6. Actually, let me mix. So 15x. 15's cancel out here. And then we have 15 divided by 3 is 5. 5 times 8 is 40. So then this is negative 9x. And subtract x from both sides because it's negative 10x. And divide by negative 10 and get positive 4. Okay. Okay, let's take a look at number 8. Number 8, we want to clear the fractions out again, the denominators, but because of the 9, it's going to make our LCM just not very cooperative. So there is a cool little trick to get this LCM, and that is if we just do prime factorization. 7, of course, is already prime, and then 9. So the trick is use every base, but always use the most bases. So like there's a 2 in here, there's a 3, and there's a 7, but I have to use the most of every base. So there's 1, 2. There's 1, 7 in each one. And then here, there's 2 3s. So I'm going to use that. So basically, that's 18 times 7. So all this is 126. So not very nice here. So 126 divided by 14, that's 9. So our new left side is a 9. And then 126 divided by 7 is 18. So, and then 18 times 6. 108. 126 divided by 9 is, we already know, it's 14, and then And then we just go ahead and solve this. Times 6, 84. And so 84 minus 108. So move the 9 to the right by subtracting it. Move the 24 to the left by subtracting it. Divide by 5, and we get 39 over 5, which can't be reduced. Okay, now let's take a look at number 9. This time we need to find out whether, or decide whether it's identity, conditional, or inconsistent. So if you remember, identity is all real numbers. Conditional is it's like when you get solutions. And then inconsistent would be no solution or the empty set. Okay. Actually, they use the null set, so that's fine. Okay. So, working down here, we get 2x, so 6x plus 12 minus 4x. Whoops. So 2x plus 12, and as you can see, these guys are identical. You don't have to continue. Those are two identical lines. If you graph them separately on a graphing calculator, it's the same exact line. So this is the identity. Okay, and the solution is all real numbers, which in set builder notation is a real number. Okay, I should have just circled that, but okay. So this is number 9, and let's move on. Okay, number 10 and 11 here. So again, same directions, and let's see what we get. So as you can see, they have the same slope, different intercepts. That's going to be parallel or no solution. But let's just go ahead and subtract these two guys. Whoops. Let me erase this. So 4 definitely does not equal 8. So this is no solution. So that would be the empty set, and this is inconsistent. Okay. Number 11, same deal. So okay, so because we have a single solution, which is -3, then this is called a conditional equation. Okay, you actually get solutions, that's a conditional. Now let's take a look at some of the stuff we found in the imaginary number system. So standard form looks like this. So we're just going to combine like terms here. So 5 plus 2, that's 7. And negative 9i plus 4i is negative 5i. Okay? So just combining like terms. Same thing with this one, but we're going to need to distribute this first. So really, we have, so 3 minus 9 is negative 6, and 9 plus 7 is 16. Okay, 14, distribute, and this time we are remembering that I squared is negative 1. So 12i minus 4i squared, which this turns into a negative 1. So that makes this positive 4. So we have 4 plus 12i. Okay, so for number 15, we have the distributive property, or FOIL. So negative 12 minus 3i. Then we have those two. So that's going to be positive 28i and positive 7i squared. You know what this I is really negative 1. So this is actually a negative 7 here. So our answer then is going to be these two together, which is 25i. And then you got negative 12 and negative 7, which makes negative 19. So this one's the same thing. Actually, you can use a shortcut if you want. So you can actually expand this out. Or just use a shortcut. Shortcut would be a squared plus 2ab plus b squared. So basically, that's just saying square the first term, square the last term, and in the middle you're going to get the same thing twice, so that's why they put a 2ab. So 7 times 6 is 42. 42 plus 42 is 84. So this is actually a negative 49 now. Okay. So 49 minus 36, that will be negative 13. So that's these two. And then you have this one in the middle. Okay, so number 17 and 18 are very similar. Looks like there's nothing wrong with these, but there's no I allowed in the denominator. We need actually standard form, which looks like that. So to get rid of the i's in the denominator, we're going to multiply top and bottom by the complex conjugate. So that means same two terms, but the middle sign is opposite. Okay? That creates a nice scenario here. So the top is going to be 16i minus 16i squared. And the bottom, if you remember what happens to, so the shortcut for the bottom is it's basically this. Okay, the two middle terms are going to be exactly the same thing. Okay, so here we have 1 times 1 is 1, and I times negative I is negative I squared, and we know that the negative I is basically a negative 1. So we know this is a negative 1, and we know this is a negative 1. So we have 16 plus 16i. And then we have 1 plus 1. Divide both of those, and you get this here. Okay, so I just remembered that this shortcut is for regular binomials, but since these are complex conjugates, the shortcut's actually a step further, and it's just, we're going to go ahead and do the I squared, which is negative 1, which turns this last term into a positive. So let's do that right this time, okay? So four minus 5i. So let's start with the bottom to make this easier. So the a squared plus b squared is basically saying 4 squared is 16 and 5 squared is 25. That's when you just cut to the chase, skip all the formality of finishing the FOIL. So basically you can just use that. So that's nice in the bottom, but the top is not so nice. So we got 12. We have negative 15i. We have 24i and negative 30i squared. And we know this becomes a positive 30 because of this guy here. All right, so let's put this all together. So the bottom is going to be 41. And the top is going to be 24 minus 15. Oops. 9i. And then 12 plus 30 is 42. Now, because it wants it a standard form, we need to go ahead and separate the 41 under both numerators. Okay. 19 and 20 and 21 have radicals in there. So before you do anything, you need to take out the i's. I'm sorry, take out the negative 1, which the square root of negative 1 turns into an I. Because remember, this is I. So these are perfect squares, so this is going to be 4i minus 6i. That's just negative 2i. Okay. So again, we have some more perfect squares here. So that's 2 times 6i plus 6 times 2i. So that's 12i plus 12i, 24i. Okay. Now the last one is just to write it in standard form, so everything is pretty much done for you. We just need to separate. Actually, we need to take care of that. So we can actually do on the side, so we can say, hey, I'm going to go ahead and take out the I, and then I need to break up the 20. I need a perfect square in there, so that's going to be, square root of 4 is 2, so this is 2i, radical 5. And then reduce, well, we got to reduce this fraction and this one. Twos cancel out. Oops, not the twos. The 2 and 24 cancel out, so it's I radical 5 over 12. Okay, so for number 22, we still have some more issues here. So again, we need to take out the I. So we need to, let's just leave it 18. So this is going to be I squared. Actually, it's better if we reduce this 18 or simplify it. So this is actually 9 times 2, which is now 3 radical 2. So I'm going to put that I in there. Okay, so So 3i times both of these now. So it's going to be 3i squared radical 14. 2 times 7 is 14. And then 3i, 2 times 5 will be 10. So the only thing we have to fix here is this I squared, which is a negative 1. So this turns into a negative 3 radical 14 minus 3i radical 10. Okay. Now we're moving on to quadratic functions, quadratic equations. So it says solve by factoring. Okay, so we want to go ahead and take a look at our reverse FOIL, x times x. And 42 is going to have a bunch, but 6 times 7, they're right next to each other, so that's going to give you a difference of 1. So we need a negative 7 and a positive 6. Negative 7 times 6 is negative 42. Negative 7 plus 6 is negative 1. So we just checked ourselves for that and that. Good to go. And so the x's are basically, so this is supposed to be equal to 0. So this is pretty straightforward. What is this x and what is that x? It has to be positive 7 and negative 6. That's my bad. So, no, I'm right. Okay. But technically speaking, you're supposed to use the zero product property. So you set each of these equal to 0 and solve, okay? Okay, same thing with 24, except we need to move both of these over here to the left side. So x squared minus 5x minus 24. Fill in this spot. It's pretty much done. Now we have factors of 24 that subtract. How do I know I'm subtracting? Because this is negative. One of the factors have to be negative. So that means we're subtracting. Okay, 6 times 4 is 24, but if you subtract those, you get 2. 8 times 5. So negative 8 times, 4. Or 3. So negative 8 times 3 is negative 24. And negative 8 plus 3 is negative 5. Okay, so we can see what the x is here and here. That is a negative 3 and an 8. So now we have number 25. We don't have a GCF because the 8. So we need to solve this or be able to factor this. Now you can try to figure this out, but I did show you guys the sneaky ninja method. And so we're going to go ahead and use that method. So the sneaky ninja method says, hey, let's go ahead and do 9 times 8. So it's 8 times C. That's actually negative 8. So that's negative 72. Okay, so factors of 72, that will get you the 21. So if we come over here to the right and fill out factors of 72, 1 times itself, and you just divide by 2, get 36. That's not going to get you 21. 72 divided by 3. Oh, there's my 21. Because this is a negative 72. So to get 21, I need to subtract 3. So basically, in the sneaky ninja, you basically ignore that 9. He disappears into thin air. And then we're going to sneak him back in right here. Okay. So this little sneaky ninja goes back in, sneaks under, and now we see if we get any whole numbers, which we do, right? I'm sorry, we have fractions in both. All we have to do is reduce it. So this is 1/3, and this is 8/3. Okay. So again, what are these x's that will make these 0? Well, the opposites. So negative 8/3 and 1/3. Okay. Okay, 26. So we want to solve, but it's missing the C term, so we want to go ahead and do the GCF. Okay, GCF. So that's going to be 7x. Okay. be 0, this could be 0. So x is 0 and x is negative 2 here. So negative 2, 0. I like to put it in the correct order, but it's not necessary. Okay, square root property is just isolate the x squared and then take the square root of both sides. So if we divide both sides by 3, we're going to get x squared equals, so x squared equals 16. And then take the square root of both sides and get plus or minus 4. Okay. So once again, you want to isolate the x. So we're going to subtract 3 from both sides and then divide by that 3. So we get plus or minus 5 for this one. Okay, let's take a look at 29. Alright, so I thought I was recording for 29 and 30, and I guess I wasn't. So here is the solution for 29. So we want to isolate this x squared, so add 9 to both sides. You got the 192, negative 192, divided by 3, negative 64. This is a perfect square, so this guy right here is going to be an I. You got plus or minus 8. Okay. Same thing, square root property, do those first. X minus 2 equals plus or minus 6. Add 2 to both sides, so we got to do 2 calculations, 2 plus 6, which is 8, and 2 minus 6, which is negative 4. And there is the solution there. So let's go to 31. So when we do the square root of both sides first, that's going to give us plus or minus 7i. So when we subtract 4, then it's going to be minus 4 plus or minus 7i. Okay, let's start using the quadratic formula. Starting with number 32. And that is x equals opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we have our a, our b, and our c. A is 1, b is 5, c is 1. So let's see what we get. So opposite of 5 plus or minus the square root of 5 squared minus 4 times a times c all over 2a. So I'm going to do this radical on the side. 25 minus 4, which is 21. Can't simplify 21, it's not a perfect square, and there's no perfect squares factors, so we leave it. That goes here. And pretty much we're done. You can't do anything else with this. So you need 2 answers for your solution set. And that's going to be the negative version and the positive version in the middle. Okay. Okay, we're going to use it again for number 33. So opposite of B, and feel free to pause this at any time, or just go ahead and work these in your review at the same time as I do them. It's going to be the same type of question, just different numbers most likely. So the opposite of b, so a, b, c, plus or minus the square root of b squared minus 4a and c, all divided by 2a, which is going to equal So I'm going to do this over here on the side as a scratch work. So negative 6 squared is 36. And then 45 times 4 is 180. Subtract those two, you get negative 144. And then this is going to be 12i. Okay? So this goes over here. And now we get, alright, so this guy right here, we're going to simplify the 6 and the 12 by dividing by 2. So the final answer then is going to be, I'm going to go ahead and put that up here. So that's going to be 3 plus 6i. And 3 minus 6i. Okay? Okay, the next few are basically just solve it however you want. And of course, this is on the computer. That's an online test, so you can do basically whatever you want to do there. So, all right. So what we're gonna do is I'm gonna do the sneaky ninja factoring, which starts off with a times c. So first of all, this is 2x squared minus 3x minus 20 equals 0. So my AC is 2 times negative 20, which is negative 40. So I'm going to ignore the 2 because he is sneaking around like a little ninja, and I'm just going to put x and x. But I am going to think of factors of negative 40 that will give me a negative 3. So that means there are only 3 units apart. So we can do minus 8 and plus 5. Those are 3 units apart. They multiply to get negative 40. Okay, so then we sneak the 2 back in here. That's the A. Okay, that's this guy right here. We sneak this 2 back in, and we have a nice whole number for this one. And this one, we can just keep it as a 5 over 2. Because we're solving, we're not necessarily just factoring. And so we can go ahead and say x equals 4 here, and x equals negative 5 halves. Okay, so our solution set is negative 5 halves and 4. Okay? As you can see, it just took a few minutes with the ninja method, okay? This one, I'm going to isolate the x squared for number 35, because I'm just going to divide by 3 first. We're missing that b term, so this makes it nice. 189 divided by 3, 63. And take the square root of both sides. So plus or minus. Well, let's just go ahead and simplify this guy right here. That's 9 times 3. I'm sorry, 9 times 7. So that means this is going to be plus or minus 3 radical 7. Okay, so you got the negative version and the positive version. Oh my goodness. Okay. Okay, so we don't have to verify our solutions yet as far as throwing a particular solution out. So we're going to be continuing with 36 here. Okay, so in this number 36, I do see a GCF of looks like 4. So if we pull this out, we're going to get 12, and 144 divided by 4 is 36. So I'm doing the factoring method, and basically it's -6 and -6. That multiplies to get positive 36 and adds up to -12, and then we can rewrite this as this here, and get divided by the 4, square root both sides. Whoops. And get x equals 6. Okay. Okay, number 37. Moving right along here, almost done. So this is something we're gonna do the GCF, which is 6x to the second. Pull that out. Hopefully make this better to deal with. So it's going to be x squared minus 4. Okay. Then we do the product. So x is definitely 0 there. Take the square root and we get plus or minus 2. So our answers then are going to be, if I do it in order, which you don't have to, be those 3. Okay? This and those 2. Next, all right, now we have radical functions. So if you remember, you can't take the square root of a negative. And if you look at the graph, it goes like this. There's nothing over here. So we do have to check for extraneous solutions, or solutions that makes the algebra true, but the algebra is correct, but it does not check back if you put the number back into the original equation. So we're going to square both sides, and then we're going to get that radical sign disappears. Now we have x squared, and then we move these guys over. So move the -5 to the right, move the positive 14 to the right by subtracting it, and now we can see a quick factoring problem, which is 7 and 2. 7 minus 2. 7 minus 2 is 5, and 7 times -2 is 14, which means our solution set is -7 and 2. Okay? And of course, we're supposed to check this, right? So I'm not supposed to do that. Sorry about that. Shame on me. All right, so we do need to check our solution. So our proposed solution was -7 and 2. Okay. Uh-oh. So let's check over here. Let's start with the 2. So 14 minus 10, that's 4, and that's 2. Okay, so he's part of it, and -7 is most likely not going to be part of this, okay? And just to double check, so without doing all the math, I mean, you can see that a square root, a cube root can equal a negative, but not a square root. So even if you did all this, it's just not going to work out, okay? So solution set will be 2. All right, we're going to continue the same theme here. Square both sides to get rid of the radical. That's going to be x plus 15. And then we have to square the binomial. So the shortcut is, that's going to be 25. So the middle term is going to be 2ab. In other words, x times -5 is -5x, and there's 2 of those, so that's -10x. Then we move the 2 terms over. So we're going to do that. Makes 11x. And this is going to give me 10. Okay? Now, factors of 10 that give us 11 would be 1 times 10. So this would be a nice, quick factoring. And then, so our proposed solutions would be 1 and 10. Let's go ahead and check those out. We can tell that the x equals 1 if you put this in here. I don't even have to calculate this. I just know that this right side is going to be -4, which is square root. It's not gonna be able to give us a -4 result. So I know that I'm going to have to eliminate the 1 and keep my 10. Okay. Okay, so moving on. Number 40. All right, this is the big guy, and I need a lot of room for this. So I'm gonna have to shrink this down a little bit. So we need to isolate. So we're gonna move this guy to the other side. Then we square both sides. So I'm going to work back up here. So the left side is x plus 10. You know what? Whoa. The right side is going to be x minus 2. And then 4. 4 in the middle there. Just trying to shorten this up a little bit since I don't have a lot of room. And then this is plus 4. Okay. So we do have like terms right there and there. And that's a positive 2. Then we're going to move both of these to the other side. So that gives us 8. Then we divide by this 4. That gives us 2. Then we square both sides, and that gives us 4. X minus 2. And then we get x equals 6. Okay? So we do need to check this to make sure that it's not an empty set or there is no solution. So So 6 plus 10 minus 6 minus 2. So this is 16, this is 4, this is 4, this is 2, 2 equals 2. All right, works out. Okay, so number 41, we're going to go ahead and cancel out this fractional power by raising it to the reciprocal power. So that's going to be 2/5. Okay, so I'm going to work down here. So x equals 32 raised to the 2/5 power. Then we go ahead and convert that to the 5th root of 32 raised to the 2nd power. So you can use your calculator to do the 5th root of 32. Hopefully you know how to do that. For me, on my basic calculator, I have to type in a 5. I have to go get that root button, which is back behind the button. Type in 32, press enter, and I get 2. 2 squared is 4. And because this was a odd root, positive, only one result. In this case, positive. If it was a even root, then it would have gave us 2 results, positive and negative. Okay, so this is going to be 4. Actually, we should just make sure and check that. Yeah, that's basically right. All right, so now let's go to the next question. Okay, number 42. 2/5. 2/5. So same thing we just did, except I have an x minus 4 on the left. And if you remember, the 5th root of 32 was the 5th root of 32 was 2. 2 squared was 4. So we get 8. Okay. So this part is calculator or do it in your head. Okay. And again, for me, I have to type in a 5. I have to type in the x root, which is any root button. Then I have to type in the 32, and then equals. Or you can do 32 raised. 32 raised to the parentheses 2/5 power. Okay, either way should give you 2. All right. 43. Let's isolate the x. So add the 22. Divide by 2. raise it to the 4/9 power. So x equals 11 raised to the 4/9. So that's going to be the 9th root of 11 squared, and that really isn't going to help much. And so because this is a decimal, and basically my math lab will let you just leave it like this, okay? Okay. Okay, number 44. We're in the home stretch here with our last two topics, which is absolute value and interval notation. So here's our absolute value. So remember, you're going to solve two equations. So here we're going to do x minus 2 equals 9, the positive version and the negative version. Okay, so plus 2 is 11, and plus 2 here is negative 7. Okay, divide, isolate, make sure you isolate. So we're going to do 2x minus 1 equals 5, and 2x minus 1 equals negative 5. X equals 3. So plus 1 would be negative 4, x equals negative 2. And so we have two solutions. Okay? Moving right along to number 46. Remember to isolate before you do anything here. So we're going to do 10x equals 3 and 10x equals negative 3. So x equals 3/10 and x equals negative 3/10. All right, and let's go to number 47. Okay, so we're in the home stretch here, we're almost done. When we isolate this guy, we're going to subtract the 4, and that's going to give us a negative. That's going to give us a negative result. And as you know, guys, just like radicals, not radicals, but square roots will not give you a negative result. Same thing with absolute value. Absolute values cannot give you a negative result. So this is impossible. So that means there is no solution. Okay, it's the empty set. Or this here. And the reason why I think I covered this in class, or in the video. So you have your absolute value here, and you're trying to see when does that intersect a negative number, which is a line down there, and that's not going to happen. It just doesn't connect. Okay. Okay, number 48. Set builder notation. Okay, so this is open on the left. This is closed on the right. Okay, because the parentheses means open, bracket means closed. So we're looking for one that has open on the left and bracket on the right. Okay. 49, closed on the left, open on the right. So closed on the left, open on the right. All right. If you get two of the same type of picture, make sure it's on the right number. All right, and now we are on the last one. So this one is open, and this one's open forever. And you should see an arrow on the right side. Okay, so out of all these, we do see some nice arrows here on the right side, but it stops at negative, or starts at -6, and it's open. So even though these two are starting at -6 going to the right, only one of them is open, and it's this one here. Okay, and that is it, guys. I hope you spend time studying for the test using this review, listening and watching me, or at least watching me, and filling out your or completing your review online. Okay, so God bless you guys, and see you in class and in the next video.